chapter Semiconductor Electronics, and so far we have studied regarding the semiconductor diodes. It is one of the application, very good application of the semiconductors, where two semiconductors join, like N-type semiconductor and P-type semiconductors form, where one junction is there, and those semiconductors, or you can say those diodes, are used like rectifiers. They are used as rectifiers, and by making use of the semiconductor diodes, some special purpose diodes are formed, like Zener diode and some photodiodes, then solar cells. Like this, we have studied the application of semiconductor diode. So today we are discussing one more application of semiconductor, that is the transistor. So what do you mean by transistor? We are studying here what do you mean by transistor, and where these transistors are applied, what is the use of these transistors, and how these can be used in our day-to-day life. We shall see what do you mean by transistors now. So transistors are the devices obtained by doping three regions. Here, as in case of diode, there are two doped regions. One is P and another one is N. So one junction were formed, but here there are three doped regions are there. In the transistor, three doped regions are there. If we have doped three regions, if I take an example, like this is what we are talking about. Here three regions are doped. This is first region, this is second region, and this is third region. Let me say this is one region, which is N, P and N. I am just taking an example. So three regions are doped, like here N-type semiconductor is doped, and here P-type semiconductor, and here N-type semiconductor. So here you can see in the transistor, three doped sections are there, regions are there, and two junctions are there. So you can define a transistor as it is a device in which three doped regions are there, two junctions are there, and if you connect the terminal, you can connect a terminal, one terminal here, another terminal here, and another terminal here. So it is two junction, three terminal device. It is simply, you can say it is a two junction and three terminal device. So that is what the transistor is. So what is a transistor? Transistor is a device obtained by doping three regions. By doping three regions, we are obtaining two junctions. And the main purpose of this transistor, is to amplify the signal. So main function of these are amplify. Means if the signal is very low, we can amplify the signal to any level. So this is all the main function of the transistor. And so I'll write the key word so that you can define it. So transistor can be obtained by doping three regions, and by that two junctions are formed. So you can say a transistor is two junction, three terminal device. So you can say this it is two terminal and two junctions and three terminal device. So as we know, we can do one part with N-type semiconductor, or you can say pentavalent impurities, trivalent impurities, and other pentavalent or trivalent impurities. Likewise, we can categorize these semiconductors. There are two types of transistors. Those two types are N-P-N transistor, and another one P-N-P transistor. So these are the two types of transistors we find in our day-to-day life. So one is NPN transistor, another one is PNP transistor. So what are these transistors? How can we define these transistors? If you see here, NPN. N means one kind of semiconductor, that is N-type semiconductor, P-type semiconductor and N-type semiconductor. Here, P-type semiconductor, a small P-type semiconductor is sandwiched between two N-type semiconductors. If you take I will take, this is N-type semiconductor and this is N-type semiconductor, and this middle finger is the P-type semiconductor. P-type semiconductor is sandwiched between, means it is placed between two N-type semiconductors. So between two N-type semiconductor, P-type semiconductor is placed. Then obtained transistor is nothing but NPN transistor. So let me write it first. NPN transistor, NPN transistor. So NPN transistor, you can say P-type semiconductor is sandwiched between P-type semiconductor, P-type semiconductor is sandwiched between two N-type semiconductor. Two N-type semiconductor. And what is PNP transistor? PNP transistor. So I will draw the block diagram for this first. If I take a block diagram, you can see here is N-type semiconductor and P-type semiconductor and N-type semiconductor. So this is N-type semiconductor and this is P-type semiconductor and this is N-type semiconductor. And you can say one connection is there and one connection is here and another connection is here. This is called emitter and this is called base and this is called collector. What do you mean by emitter, what do you mean by base and what do you mean by collector? We shall see in the forthcoming minutes. So this is what NPN transistor. You can see here P-type semiconductor is placed between two N-type semiconductors. Similarly, if I tell to define PNP transistor, how can you define? Name itself is indicating that N-type semiconductor is placed between two P-type semiconductors. Same definition you have to write. First, N-type semiconductor is sandwiched between two P-type semiconductors. Like if I take three fingers, this is P-type and this is P-type, and mid finger is N-type semiconductor. So N-type semiconductor is placed between two P-type semiconductors. Then obtained transistor is called as PNP transistor. So you can write N-type semiconductor, sandwiched between two P-type semiconductors. So how can you draw its symbol? So here, very simple, you have to draw. It is what? P section, and this is what? N section. So it is P and it is N, another one is P section. So here one terminal, here another terminal, and here this is called emitter and this is called base and this is what? So this is regarding the PNP transistor and NPN transistor. Here you can see if this NPN transistor is there, two N-type semiconductors are there, and we know that in N-type semiconductor majority charge carriers are electrons. And minority charge carriers are holes. So I can say that in NPN transistor majority charge carriers are holes are very few, number of electrons is very more. So you can say that in NPN transistor majority charge carriers are electrons. Here the majority charge carriers are electrons, and here if you see in the P-type semiconductor holes are in majority charge carrier. Here also holes are more, and very few electrons are there. So you can say in a PNP transistors, holes are majority charge carriers. So you have to remember, if NPN transistor, electrons are majority charge carriers. If PNP transistor, holes are majority charge carriers. So this is regarding the introduction transistor. Just go through what I have written. So first, transistor, I'll recall it once again. Transistor can be obtained by doping three reasons. It may be NPN transistor or PNP transistor. If we dope three reasons, we are getting three separate semiconductors and two junctions. If I provide the connection to all those three semiconductors, then I'll get three electrodes, or you can say terminals. So this transistor is nothing but two junction and three terminal device. You can say two junction and three terminal device, right? And it is electronics device, and its main purpose is to main application is amplifying the signal. So it amplifies the signal. Main function is amplifying the signal. And in the transistor there are two types. One is NPN transistor, another one is PNP transistor. NPN transistor, P-type semiconductor is sandwiched between two N-type semiconductors. I have written here, and this is what the block diagram. P-type between two N-type. And PNP transistor, you can see one N-type semiconductor is sandwiched between two P-type semiconductors. This is regarding the introduction of transistor. Just take out the screenshot so that you can make a notes. So hope you have taken out the screenshot, and see, you have got already printed notes. You have already got the printed notes, hard copies. So please note down the points what I have suggested here and make the notes, because it is very important to make your own note and read those notes so that you get a clear picture of the thing. So next topic we have studied the PNP and NPN transistors. Let us have their symbol. I am drawing the block diagram. Thereafter I am noting the symbol. Then first we are talking about NPN transistor. So its block diagram consists of two N regions, one P region. You can say it is N region, it is P region, and it is N region. It is what the emitter is. What do you mean by emitter? I will tell it. It is base, and it is what the collector is. Right? So how can we represent this one? By the symbol. This is what the symbol. See, symbol, it may be NPN transistor, it may be PNP transistor. You draw a circle first. And draw a horizontal line. Or you can draw a symbol like this also. First draw the line, straight line, then draw two inclined lines. So this whatever you have drawn, it becomes the base. Right? Now, one of these is a collector and one of these is emitter. I am drawing the same structure here also. So one of this is base and one of this is collector. Then how can we say which one is collector and which one is emitter? Then see, if you are talking about NPN transistor, in NPN transistor base is P. So this is what the base is. So I am marking P here. This is what the base is. So I am marking P here. Right? Now, and if it is P, these two becomes N and these two becomes N. This one is N and that one is N. Now, how can you differentiate the base and collector? Base and collector can be differentiated by an arrow mark. Right? So this is what the arrow mark is. It is simple, like arrow mark always from positive to negative. Means it is showing the direction of current flowing through it. It is positive to negative. Now where you have placed the arrow mark, that becomes emitter. That becomes emitter, and where there is no arrow mark, that becomes collector. Similarly here, it is emitter is, this is emitter, N reason, and this is collector, N reason. So where you are drawing arrow mark, that becomes the emitter, and this is base reason. Without the arrow mark, you can see that is the collector. So we will talk about the PNP transistor, PNP transistor. PNP transistor. PNP transistor is also like we will show the block diagram first. This is what the block diagram is. Two P regions here, two P regions and one N region. This is what the emitter is, and this is what the collector is, and this is what the base is, and this is what the collector is. Now how the symbol will be? Symbol is, first you draw the base one, first you draw the base, then you draw collector and emitter. So collector and emitter. Here N is the base, so I am marking here N, and this is P and this is P. So here always show the arrow mark from positive to negative, because the conventional the direction of the current is from the positive to negative. So I am showing the direction from P to N. So this is what the direction of current. So I am showing the direction here, means this becomes E and this becomes collector and this becomes base. Similarly, like this, if I am drawing, means this is what the base is, means it is what the N will be, and we are marking two inclined lines where the arrow mark is there is P. So arrow mark must be from P to N. This is also P. This becomes emitter and this becomes collector. So remember these symbols in the PNP and NPN transistor. NPN transistor, arrow mark is going out. Arrow mark is going out from the circle. And in PNP transistor, arrow mark is coming in to the circle. You can say it is coming in, and here in the NPN transistor it is going out. Means current is going out and current is going in, you can say. And arrow mark, wherever you are putting the arrow mark, that terminal becomes emitter, like this. Here arrow mark is there, and this is emitter, and where there is no arrow mark, that is what the collector is. So these are what are symbol for NPN and PNP transistor. So just take out the notes, take out the screenshot, and make the symbol, draw the symbol neatly. Just take out the screenshot. Hope you have taken out that screenshot. Now we shall study what you mean by emitter, what you mean by base, and what you mean by collector. So first, let me draw one reference diagram, transistor diagram, so that we will get a clear picture of what we are studying. So this is what the NPN or PNP transistor. This is, I am taking example N transistor. This is what the emitter is, and this is what the base is, and this is what the collector is. Now, how can you define emitter? How can you define the base? And how can we define the collector? We shall see. So first, we will see about the emitter. What do you mean by emitter? Is emitter is placed at one side of the transistor. It is the side region of the transistor. So it is one of the side of the transistor. And what you have to remember is, you can compare the size. If you compare the size of this emitter and this base, its size is larger, quite larger. And if you compare the size of emitter and collector, then the size of this emitter is bit smaller, right? So, but what we have to remember is here charge carriers are more. Here the charge carriers are more compared to other two reasons. Charge carriers are more means it is doping is more. Here the doping is more. Doping is more means you can say it is highly doped. So remember, emitter is a side section, one of the side section, and it is highly doped and moderate in size. Its size is moderate. Its size lies between the size of base and size of the collector. So what about the size? Size is moderate. And right is one of the side section, side region, and highly doped and moderate in size. Moderate in size means size lies between base and collector. Now here charge carriers are more. Remember, in the emitter there are number of charge carriers are there. Number of charge carrier means it can send n number of charges to any of the sections like base or the collector. So you have to remember, as the name indicates, it emits the charges, or you can say charge carriers. So here while defining, you have to remember 2 points while defining the emitter. It is highly doped and moderate in size, and it is emitting the charge carriers. Because of this reason, it conducts the current. So second one is the base. If we talk about the base, if you see the size of the base, and compare it to the emitter and collector, its size is very small. So first point, its size is very small. And it is lightly doped. Here the impurities are very few, lightly doped. So here we have to remember the size of this is very small and lightly doped. Doping is less and smaller in size. And it forms, if you see the base, it forms the two junctions. Like one is emitter base junction, another one is collector base junction. You can see here, this one is the junction between emitter and the base, and here is the collector and the base. So it forms two junctions. It participate forming both the junctions, or you can say two junctions. So these 2 points are you have to remember while writing the notes regarding the base. Next one is collector. So collector, if you compare the size of collector with the size of base as well as emitter, you can see here collector's size is much larger compared to both. So it is large in size. And talking about the doping, it is moderate doping. So here the doping is more compared to P region but less compared to emitter region. So here doping is less compared to base and more compared to emitter region. So it is moderate doping, you can say. So what point you have to remember? First point is doping is moderate. And size is large. So its size is very large compared to another two sections. And one more point, as emitter emits the charges. It indicates it emits the charges, and here in the collector charge carriers numbers is less because doping is very less. Hence it collects the charges. collects the charges. It collects the charges. So this is regarding emitter, base and the collector. So emitter emits the charges, and here doping is more, as well as its size is moderate. And talking about the base, size is very less, doping is moderate. You can say doping is also less and size is very small. And you can say it participates in forming two junctions. Those junctions are EB and CB, emitter base junction and collector base junction. And talking about the collector, its size is larger, quite larger compared to both the regions. Both the regions, its size is large, and you can say here doping is moderate. Doping is moderate. So these are the points you have to remember while defining emitter, collector, and base. If I talk about emitter and base and collector, we are dividing these three based on their size and doping. I'm just drawing a simple table so that you can remember. Okay? So that you can remember. Here, emitter size is moderate, and doping is very high. You can write huge. So base is size is very small, or simply I am writing small, and doping is low. Doping is low, and size of the collector is very large in size. You can say large, and doping is moderate. So if you remember this table, you can remember what you mean by emitter, what you mean by base, and what you mean by collector is. So just write it all these things. Define what you mean by emitter, what you mean by base, and what you mean by collector by taking these notes and also this block diagram, and remember this table so that you can remember easily. So this is regarding the base, emitter and collector. Just take out the screenshot so that you can make the notes.